Hi, welcome back to part two. Hopefully we won't have too many wordy questions. So question 6 or 22, part A, write this in standard form. So if we're to write this as a number between 1 and 10, we're going to go with 2.84. Okay, so we just get that value, shrink it down, and it's going to be multiplied by 10 to the power of, and we need to work out what that power is. I can just remove that there. I might even zoom in now. Our decimal place originally is here, and I'm going to count how many times it moves. 1, 2, 3, 4, 5, 6, 7, 8, 9 times. And therefore, it's 10 to the power of 9. Some people have shortcuts for let's just count the zeros. That only works when you have a number that's small. So you're counting a 0.00000 value. You can count the zeros there, just like we can for part B. So as an ordinary number, it's 0. That's 1 0, 2, 3, 4 zeros, and then we write the rest of the digits out. So 2, 5. Okay, because if it was, the decimal place was there, we go backwards 1, 2, 3, 4 positions. It has 4 zeros. Okay, question 7. Chen invests 40,000 won in a fixed term bond for 3 years. It pays compound interest. It's good. This is what our classes worked on just before the Easter break. Work out the investment at the end of 3 years. So 40,000 is going to be increased by 1.035. So 3.5%. If you don't know where I've got that from, 100% plus 3.5% equals 103.5%. And then you divide that by 100 to get that decimal multiplier. That's really important because that's just 1 year. And actually, if you really struggle with this in the exam, put this down, you get yourself 1 mark out of the 3, which can't be bad. But because it's going to be 3 years, we're going to cube it because it's times by 1.035 once, twice, and then 3 times. Okay, calculator time. The last mark is going to be an accuracy mark, which we love. And that gives us 44,348.715. It wants it to the nearest one, which is 44349. Okay, hopefully you're happy with that. Part B. Wang invested some yuan. The value of his investments decreased. That's not a good investment. At the end of the first year, it was that. Okay, so he has P. It's gone down by 6.5%. So 100% take away 6.5%. Don't take risks. Put it in your calculator. That's 93.5%, which as a decimal is 0.935. Then the answer was 30481. So in order to work this out, we've got to divide like so. Okay, so we're working backwards, kind of traveling back in time in our time capsule to work out what it was initially. Well, we're reversing what's happened, and that gives us 32,600. Okay, 3 marks again. I know some of our candidates struggled with this question, reverse percentages. Really important topic. Do look it up. Corbett Maths do some really good stuff on it. Okay, question 24. Not sure I want to do this one. Looks a bit wordy, looks a bit shapy. So the region shown, or the region shown shaded in the diagram is a path. Of course it is. They wouldn't do ordinary paths, would they? The boundary of the path is formed by 2 semicircles with the same center and 2 straight lines. The inner semicircle, radius of 7, that's shown in the diagram. The path is 2 meters, that's shown in the diagram. Don't need to worry about that. Actually, don't really need to worry about that either. That's just all nonsense. Work out the perimeter of the path. That means it's all the way around the outside. Okay, so we know that's 2. We know that's 2. We know that is going to be half of a circumference. We know that it's going to be half a circumference. In fact, what I'm going to do here is I'm going to colour that in pink. And I'm going to work with the colours. So because we've got 7 here and 2 there, that's going to make a radius of 9, which is a diameter of 18. We then multiply that by pi, and then that would give us the circumference if it was a circle. And then if we divide that by 2, we get that distance, which is 9 pi. It's actually going to be easier than I thought. The next one is 14 times pi. divided by 2. Where's 14 come from? Well, you double the 7 because you've been given a radius and you need a diameter, and that gives us 7 pi. What's lovely here is it's going to be 9 pi plus 7 pi, which is 16 pi. And then we add our two little bits here, 2 and 2, which gives us 4. Finally, it wants it correct to one decimal place. So 16 plus pi plus 4 gives me 54.265482246. And to one decimal place, that makes 54.3. Done. That wasn't as difficult as we thought. And actually, if you take a look at it, look how many words are written on there we don't actually need. So all good. Right, question 2, simplify this. Right, now, x to the a to the power of b is x to the power of ab. So we can do the letters first. So x to the 3 times 4 is 12. Y to the 5 times 4 is 20. It's the number that people struggle with. This is going to be 2. Actually, I'm going to call that 2 to the 1. So 2 to the 1 times 4 is 2 to the 4. And we can then work out what 2 to the 4 is. It's 16. So our answer here is 16, x to the 12, y to the 20. All right, factorize. I love a good factorized question. When we've got a quadratic and it's got 3 terms, we're going to put it into double brackets because the outcome of x times x will be x squared. Then we need two numbers that are multiplied to make 36 or negative 36, and they're going to add to make positive 5. Immediately, I think I see it, minus 4 and plus 9, because that's going to make negative 36. And then 9 take away 4 will make 5. So it doesn't matter what way around you put them, in that you can have plus 9 in the first bracket and minus 4 in the second bracket, but you can't swap those signs over, otherwise you'll get a different value of the x's when it's multiplied out. Now, hence means use your previous answer. And my class said, oh, you just take the numbers and swap the signs. Yes, we take the numbers and we swap the signs. So x can equal 4 and x can equal negative 9. For further explanation, it's because if x equaled 4, for x minus 4, x plus 9, we would have 4 minus 4 and 4 plus 9 being multiplied together, which gives us 0 times by 13, which will equal 0. So you want to get a number that's going to make one of these brackets equal 0 in order to solve. Okay, question 10, the last one, and then that's one video done. Only another 11 to go for this series. Here is an isosceles triangle, ABC. D is the midpoint of AC and DB, which is fine. DAB is 65, that's fine. Work out the perimeter of the triangle. Okay. This is naughty. So first thought's Pythagoras and probably a little bit of trigonometry as well. So we can work out AD. Oh, I don't want to write that lowercase, that's going to confuse people. So we can work out AD, and I'll just model that down here. We've got 65, we've got a length of 16, and we'll call that x. So because 65 is where it is, we've got, I'll change the color of my pen, the hypotenuse here, the opposite here, and the adjacent here. So we're going to use tan, TOA, tan 65. We've got 16 at the opposite, and then x is there. That means that we're going to do 16 divided by tan 65. And if you've forgotten your trigonometry, I've done a revision video on it years ago. I remember when I used to live in my Felixstowe house. So yeah, you can look back at that revision video and have a go at it. 16 divided by tan 65, type it right. And that gives us, I'm going to round that to 7.46. Okay, that's that. I can now work out this bit, which I'll call y. In fact, I'm going to now colour that pink. Also, don't forget that 7.46. We're going to double that in a minute. But we've now got a little triangle. Ignore the angle now. Don't really need the angle. But we've got a height of 16, 7.46. We can work out y by using Pythagoras' theorem. 16 squared plus 7.46 squared will equal y squared. And then you have to square root your answer. So that gives me 311.6516. Square root it. Y equals 17.65. Okay, finally. We need 2 of those, don't we? So we need 2 lots of that. 17.65 plus 17.65 plus, and we worked out that AD was 7.46, and we need 2 of them. Why do we need 2 of them? Because we worked out AD, and if we have 2 of them, that gives us DC as well. So add these together. 17.65 plus 17.65 plus 7.46 plus 7.46, and that gives us 50.22. And that's it. That's the paper. Just going to double check. Oh, it wants it to 1 decimal place. So 50.2. There we go. Right, that's the paper. That's Project Crossover. Good luck. I'll try and get paper 2 done soon. Hopefully your revision is going well, and I'll see you next time. Bye-bye.